Let us move forward and discuss the second type of hole, which is a standard hole. As of now, we have discussed the simple type of hole, and we have seen different profiles under the simple category. Now let us understand what is a standard hole. In order to turn it on, we have to simply press on the icon with the left click, and after clicking on it, we can see different set of options on the right hand side. Now, if we are working in industries and we are wanting to create holes for different screw sizes or different purposes, there are specific standards which are followed. Creo has inbuilt options which will help us to directly generate those kind of holes. So before that, I'll just go to shape. So you can see presently the thread type is selected to ISO. We have the different options over here, that is UNC and UNF. So these are the standards which are followed across different manufacturing industries, and we have the respective screw sizes for each standard. Clear? So let me see what is there in ISO. So under ISO, we will be having the designation with respect to M series. We have the hole over here. For example, let me click on M7. So you can see the hole generated over here. So if we are selecting the M7 by 75, it is not required for us to enter any dimensions. So the Creo will be creating it automatically because these are the standards which are pre-installed in the Creo software. And you can see the change in the dimensions over here when I'm changing the size or the screw size. Say for example, let me now go to M14 by 1, and you can see the variation in the shape as well as the dimensions. I can change it to, for example, let me increase and go to M24. You can see the screw size has been increased and also the dimensions have been varied because of that. So these are the standards. So if we are given the standards we are asked to prepare or generate a hole. Say for example, if I want to create a hole of M24 by 3, so I need not be bothered about going to simple hole and creating the specific depth or the diameter. We can simply go to the standard and we can choose M24 by 3 if we are working with the ISO standards. If we are asked to create a hole from some other standard, say for example UNC, it will be having its own different features. We can select it, say half 13. We can just go to that particular location and select the particular option over here. Clear? In order to generate the respective hole. So these are the standards which are generally followed, and if we are changing to tapered, you can see some different options over here as well as the change in the shape of the hole. So you can see the variation with each setting. Let me turn off the tapered and let me go back to ISO. So these are the standards which can also be altered manually. If we are wanting to change the depths or the angles, we can change it. But if it is a standard, it shouldn't be changed usually. We can also add a countersink to this, and we can also add a counter bore for this particular holes. Let me add some distance for this. Say for example, yes. So this is very larger actually. So if we are seeing in the total view, you can see this. We got the hole. And when we are completed with the required adjusting of the hole or setting the dimensions, we will be getting a note over here stating the type of hole which we have created. So this kind of note is only present if we are selecting the standard or if we are working with the standard type of holes. If we are working with the simple manually created holes, the whole dimensions which we are asked to create, if we are following our own dimensions and all, and if we are working under the simple category or the simple type, then we will not be getting any nodes over here. We will be simply getting the feature which can be seen on the screen. I'll just turn it again to simple and press OK. So you can see there is no node present over here. We can only see the feature. So the last thing what I want to show over here is the toggle lightweight geometry option. So this is specifically used if we are working with many number of holes, plenty of holes in the geometry. For example, if we have geometries with, say for example, 60 or 80 holes in the single geometry, then what happens is our particular system usually gets hanged a bit. I mean, it delays or it stops us. I mean, it requires a lot of graphical memory for this. So in order to avoid all the delays or lag in the system, we can turn on the toggle lightweight geometry. So what this does is, I'll simply press OK and show you. It basically eliminates the hole, but a hole is present over there. It is not visibly seen on the screen. The feature is removed. We can only see the axis and the circular sketch. So this indicates that a hole is present over here. And this will basically not get involved in the graphical memory, or this will not delay your system or lag your system to work. And you can also have a feature ready with this. If you want to visibly see it, we can simply go back to hole, edit definition, and we can turn off the feature, press OK. You have the feature with you. So I repeat, this option is only useful when we have plenty of holes in a single geometry which is obstructing the smoothness or the usage of the system which we are working with, because holes, rounds require a lot of graphical memory as far as I've used so far. So let us move forward and discuss the next engineering features in the next video.